Hello folks. Moving forward, all the concepts would be on functional understanding of components used in automation. One of the most primary topics is to see how relays work. It's relatively easy for anyone with an understanding of relay type control to program the controllers used in automation with little guidance. Some of you must have already used relays. Relays are used in our day-to-day devices like refrigerators, washing machines, heaters, air conditioning, and numerous other equipments. The earliest application of relays started during long-distance telegraphy, wherein when you pressed and released a letter to type, it interrupted the current flow. The signals traveled through the wire from transmitter to the receiver. Here, the pulses turned the electromagnets on and off, pulling and releasing a lever. A pencil at the bottom of the lever recorded the code on a moving paper. In fact, some of the first computers ever built used relays to implement Boolean gates. As we can guess from the applications, a relay is used mostly as a switch. But do you know that relays operate on low power? And moreover, to control very high power machines and tools. Let's demystify relays. A relay consists of two separate and completely independent circuits. That is, control circuit and load circuit. One circuit drives another. The components which make a relay are electromagnet, armature, and spring. Let us first understand an electromagnet. We take a metal rod and wind a conductive wire, usually insulated copper, around it. It is powered using a battery. An electric current has the ability to produce a magnetic field in a plane perpendicular to the direction of current flow. Electromagnet uses this principle. Current is introduced only when the switch is closed. That is, when current flows, it energizes the coil and creates a magnetic field. Electromagnets are useful because you can turn the magnet on and off by completing or interrupting the circuit respectively. Let's see the armature. As we can see on the screen, there is a magnetic object near an electromagnet. It can be moved when the coil is energized with electric current. Basically, the armature acts as a switch to complete the second circuit. When current runs through the control circuit and energizes the coil, it creates a small magnetic field which pulls the arm of the switch towards the coil and completes the second circuit. Thus, the light glows. When the electromagnet is not energized, the spring pulls the armature away and the circuit is not complete. In that case, the light is off. These parts are safely held with the help of a spring and inside a casing. That is the detailed understanding of relays. Isn't it simple? You can make a relay at home with these simple components. There are more information on relays in the next set of videos. Stay tuned and happy learning!